Summing up. A. The dual nature of light. Light exhibits properties of both waves and particles called the wave-particle duality. For example, as electromagnetic waves in diffraction experiments and as particles in the photoelectric effect. The characteristic parameters of electromagnetic waves are speed, wavelength and frequency, given by c equals lambda multiplied by v, where c is the speed of light. Particles of light are called photons. Each photon is associated with energy expressed by the equation E equals h multiplied by c divided by lambda, where h is Planck's constant. B. Bohr's model of the atom. According to Bohr's model, electrons move along fixed orbits. The electron orbits are associated with specific energies, discrete or quantized. These orbits are also known as energy shells or energy levels. The lowest energy level available to the electron is called the ground state. If an electron gains sufficient energy from an external source, it can move to a higher energy level, termed an excited state. From the excited state, the electron can fall to a lower energy level, emitting energy in the form of light. The energy emitted is expressed by the equation E equals hv. C. Atomic levels model. According to the atomic levels model, the electrons are arranged in 7 principal energy levels surrounding the nucleus. These energy levels correspond to the principal quantum number n. Each energy level is divided into one or more sublevels, historically referred to by the letters S, P, D, and F. The maximum number of electrons that can occupy an energy level is given by 2n to the power of 2. D. Electron configuration of elements. The complete representation of the sublevels occupied by all electrons in an atom or an ion is called the electron configuration. The sum of the exponents appearing in the electronic configuration corresponds to the number of electrons possessed by the atom. E. Orbital model. Orbitals are the regions of space around the nucleus where there is the highest probability of finding electrons. From the wave equation, quantum numbers are obtained which describe the characteristics of the orbitals and the distribution of electrons. The principal quantum number n specifies the energy content of the electron, which depends on the distance from the nucleus. N therefore defines the dimension of the orbital. The secondary quantum number, L equals 0, 1, n minus 1, specifies the number of orbitals with different shape that can exist in a given energy level. The magnetic quantum number, m equals minus 1, 0, plus 1, specifies the orientation in space of an orbital of a given energy, n, and shape, L. The spin quantum number specifies the orientation of the spin axis of an electron. ms equals plus half or minus half. The Pauli exclusion principle states that no two electrons in the same atom can have identical values for all 4 of their quantum numbers. Therefore, no more than 2 electrons can occupy the same orbital, and that 2 electrons in the same orbital must have opposite spins. Electrons first occupy the orbitals with the lowest energy, and then those with higher energy. If there are orbitals of the same energy, electrons of parallel spin first occupy each empty orbital, and then the semi-empty orbitals are filled.